Hello again. In the previous lesson, we evaluated trigonometric functions using the unit circle. Now we're going to graph sine and cosine. The graphs of sine and cosine are wave graphs. They repeat over and over, so we need to understand their amplitude, their period, and their key points. So let's begin with the quick rules. Basic sine and cosine have an amplitude of 1 and a period of 2 pi. Basic sine and cosine have a period of 2 pi and an amplitude of 1. So for y equals sine, or excuse me, y equals a times sine bx, or y equals a times cosine bx, the amplitude is equal to the absolute value of a, and the period would be equal to 2 pi over the absolute value of b. Now we're going to use 5 points to sketch one full cycle to show you what those graphs look like. So the main idea is this, that the amplitude controls the height and the period controls how long it takes for the graph to complete one full circle, okay? Or one full cycle, excuse me. So let's look at example number 1. Example number 1 tells us to graph this common function, or the basic graph of sine, okay? So y is equal to sine times x, or sine parentheses x on this interval. Use the 5 key points. Now I've already sketched the graph so that it wouldn't take this video long to produce. So in other words, the amplitude of these functions would always be from 1 to -1. Same for cosine x, as you can see in example number 2. Okay, so this is what the basic function would look like. Notice this one starts at 0, this one starts at 1. And we're going to look at it based on these intervals here. Okay, so the basic sine graph, again, starts at 0, and it goes up to 1 up here, and then it returns to 0 again, right? So it starts at 0, goes up to 1, that's the amplitude, and then it comes down to 0, and then it goes down to -1, and then it goes back up again, and then it'll just repeat that cycle over and over. Okay, so if we were to evaluate it based on x, remember this is the x-axis, so we're evaluating it on the basis of x. We evaluate it on the basis of x, then we can determine what the x value would be, or what the y output would be at the x location. So what is sine at 0? Sine at 0 is equal to 0. So that point is 0, 0. Okay. Next, we have sine at pi over 2. Sine at pi over 2, notice it goes up here. This would be the output. Darker. So sine at pi over 2 would be 1. So that point is pi over 2, comma 1. Next, we have pi. So again, it's going to go through 0. So at pi, it's going to be 0. So that's pi, comma 0. And then it's going to drop down here. So at 3 pi, notice at 3 pi, it's going to be at 1 again, or this time is -1. So at 3 pi over 2, it's going to be -1. That's the point. And then it's going to come back up here and cross here at 0 at 2 pi. So at 2 pi, it's going to be back at 0. So 2 pi 0 would be that point. Okay. Now, just to recap, so it's going to be, this is the basic function for sine on between these two, between this interval. Can the interval go out further? Sure, if we wanted to keep checking it, but guess what? It would just, you would just see a consistent pattern. It would go 0, 0, and then this would be the cycle. It would be pi over 2, 1, pi over 3, 0, 3 pi over 2, -1. 2 pi over 2 pi 0, and then it would just keep going higher and higher, and the pi's would keep getting increasing. But this is this 0, 1, 0, -1, 0, 1, 0, -1 would continue to be the sound wave of sine x. Okay, let's continue. Oh, as a matter of fact, I better say this. So again, the amplitude would be 1. the period would be 2 pi, which is where we ended here. So let me write that down here. So the amplitude is 1. The period is 2 pi. And let's just say, we'll say the midline right here is right here, which would be 0. Okay. All right, let's continue. Okay, so just like the previous example, we're looking at the same interval. So we need to find out what cosine would be at 0. So as you can see, cosine begins here, right, at 1. So cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine at pi would be -1. Cosine at 3 pi would be 0. Cosine at 2 pi would be 1 again. Okay? And then those points would be 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and then 2 pi, 1. Okay? So again, the key points is 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi over 1. And as you can just see, 0, 0, 1, and then 2 pi 0, pi -1, 3 pi 0, 2 pi 1, right? So the amplitude is 1, right? The amplitude is 1. The period is 2 pi, and the midline is y is equal to 0. Okay, so the easiest difference to remember is this: sine starts at sine starts at 0, and cosine starts at 1. Okay, now for y is equal to 3x, or excuse me, y is equal to 3 sine parentheses 2x, state the amplitude, period, and 5 key x values for one cycle. Pause the video here and try this problem. Okay, so again, remember the amplitude is equal to the absolute value of a, and the period is equal to 2 pi over the absolute value of b. Okay, so we have the equation already written here for us. The equation is y is equal to 3 sine parentheses 2x. And if you recall, we're looking at sine, so this would be y. If we compare this, would be a sine parentheses bx. So this tells me what my a is, this tells me what my b is. So a is equal to 3 and b is equal to 2. So the amplitude is the absolute value of a, right? So the amplitude, let's come back over here, for the absolute value of a would be the absolute value of 3, which is 3. So this is the amplitude. And now we can find the period as well, because we already have b located here. So that would be 2 pi over the absolute value of 2, which would be 2 pi over 2, which would simply be pi. So the period is pi. Now, essentially, what we can say is a quarter of this would be 4, or excuse me, would be pi over 4, right? So if we start at x equals 0 and then add pi over 4 each time, we'd have 5 key values or 5 key x values. Okay, so a quarter of pi would be pi divided by 4, right? So if we wanted 5 key values, let's just say we start at, okay, and that's just the safest way to do it, is to start at x equals 0 each time. If you have to come up with 5 key x values, so we could essentially say those 5 key x values would be 0, pi over 4, pi over 2, and then 3 pi over 4. Okay, so those would be essentially the key x values. So that's 1, 2, 3, 4, and then we need another. So we just use pi. Okay, I'm just gonna say that's what we're essentially doing. So this will be 1, 2, 3, 4, 5, 5 key points. Okay. Now the sine shape is, as we looked at the beginning, it is 0. Okay, so it goes 0, then maximum, then 0, then minimum, then 0, right? So just to show you again, it goes 0, then maximum, then minimum, or excuse me, 0, then max, then 0, then min, then 0, then max again. Okay, so since the amplitude down here is 3, the y values are going to be what they would be, but amplitude by 3, or amplified, I should say, by 3. So 0, or excuse me, so these points right here would be amplified by 3. Okay, so that's how you got to think of it. So this would be amplified by 3, which would be obviously 0, amplified by 3, which would be 3, amplified by 3, which would be 0, amplified by 3, which would be negative 3, amplified by 3, which would be 0. Okay, so again, the way it would look with respect to this would be 0, which would be 3, which would be 0, which would be negative 3, which would be 0. Okay, because again, these are standard intervals of sine. Okay, disregard this start at x0. So again, these are the 5.0, pi over 4, pi over 2, 3 pi over 4, pi. Okay, pi over I cut it down a little bit different. These are cut into 2s, but if you were cut into 4s, this is essentially what it would look like. Okay, all right, so again, those key points would be 0, 0, pi over 4, 3, pi over 2, 0, 3 pi over 4, negative 3, pi 0. Okay, very good. All right, let's continue. Example number 3. Example number 3, graph with amplitude and period. Okay, so y is equal negative 2 cosine half of x, and then state the amplitude, period, reflection, and then key 5 points. Okay, all right, so first of all, I'm going to rewrite the problem down here. Y is equal to 2, negative 2, cosine 1/2 times x. Okay, so here we know what the a is, we know what the b is. A is going to be equal to negative 2. B is going to be equal to 1/2. Okay, so the amplitude is the absolute value of a. We want to take the absolute value of negative 2, which would be 2. And what this means is the negative sign does not make the amplitude negative. It reflects the graph across the x-axis, okay? So this is essentially saying that it reflects across the x-axis, all right? Okay. Now we need to find the period. So the period is 2 pi over the absolute value of b. So 2 pi over the 1/2, which is 2 pi multiplied by 2 over 1. When you're dividing fractions, you need to multiply by the reciprocal. So this is essentially saying 2 pi over 1 divided by 1/2. So 2 pi times 2 over 1. 2 pi times 2 would essentially be 4 pi. So one full cycle has a length of 4 pi. That's essentially what this is saying. Now divide the period, now what we're going to do is essentially divide the period into 4 equal parts, okay? So period 4, matter of fact, is essentially 4 pi divided by 4, which is equal to pi, okay? So again, the 5 key x values would be 0, pi, 2 pi, 3 pi, 4 pi, okay? So the key x values, again, would be 0, pi, 2 pi, 3 pi, 4 pi. Okay, and we're going on the basis of this right here. Okay, so when you divide it into 4 parts, you get 1, 2, 3, 4, and we would be we're essentially going on the basis of pi. So if we were dividing 4 pi by 4, we would end up with pi, which is why each x is being separated by just 1 pi. Okay, so 0 from 0, you add a pi, you get pi. You add another pi, you get 2 pi. You add another pi, you get 3 pi, etc. Okay. Now, to find the y values, basic cosine starts at 1, 0, negative 1, 0, 1. Okay, so basic cosine is 1, 0, negative 1, 0, 1. Okay, so that's the interval. Now, if we multiply this by the amplitude, or -2, right? Which is what the original problem tells us to multiply by, the -2, then we would get -2, right? Then we would get 0, then we would get 2, then we would get 0, then we would get -2, right? So you're progressing from the basic to whatever this number tells you to do by multiplying what it would be, or what the y would be, before the amplitude and then after the amplitude. Okay. So again, if we did this, if we compared the change of this problem, what would happen? We would have okay, we would have 0, pi, 2 pi, 3 pi, 4 pi. Okay. And then those would be -2, 0, 2, 0, -2. Okay. So again, the amplified, or excuse me, the amplitude would be 2, right? Notice the distance between it, right, would be 2. The distance between it would be 2, be 2, 2, 2, okay? So the amplitude, put that over here, is 2. The period is 4 pi, right? It reflects across the x-axis. And we have a midline that is y is equal to 0. And then you can plot these points to see what it looks like, to see the smoothness of it. Because of the negative sign, the graph starts at -2 instead of a +2. Okay, because of the negative sign here, it's going to start at a -2 rather than a +2. All right, let's continue. Example number 4, write an equation of a sine function with amplitude 4, period pi, and midline y equals 0. So we want a sine function in the form of y equals a sine bx. Now, the amplitude is 4. So the amplitude would be the absolute value of a, is the absolute value of 4. That equals 4. So we're going to choose a is equal to 4 for this particular problem. And then period is pi. Oh, as a matter of fact, you can't see that. Pardon me. The period is pi. So the period being pi, we're going to use the period formula, which is 2 pi over the absolute value of b. That's 2 pi over pi. As a matter of fact, let me see. The period equals pi. Okay, so that's actually saying this instead. Okay. So the period equals 2 pi over the absolute value of b, but the question says that a period of pi. Okay, that's very important. So the period of pi is essentially what we're looking for, and this just so happened to be the same. It says the amplitude of 4, so the absolute value obviously is 4. Okay, so what we need to do here is we need to solve for b. Okay, we need to solve for b. So how do we do that? So this is the way we would do it. We would say 2 pi is equal to pi times the absolute value of b. Okay, and so what I did down here was I basically took the absolute value, multiplied it to both sides. Okay, and so this would simplify, obviously. So it'd be 2 pi, and then this is how we got this right here. So 2 pi equals pi times the absolute value of. All right. Now what we can do here is we can simply divide pi to both sides. That would give us 2 is equal to the absolute value of b. Okay. So 2 equals the absolute value of b. So therefore b is equal to 2. Okay. So now we found a and b, and it says the midline is y is equal to 0. So what does that say? That says that there is no vertical shift. Okay. If y is equal to 0, there is no vertical shift, just as well as the standard ones that we've been working on. Okay. So what this says is that y is equal to 4, right? That would be the amplified for the a sine, and we have b. In this case, it would be 2x, and that would be our final answer. Let's look at a common mistake. So a common mistake is a student says that y is equal to -5 sine x has an amplitude of -5. correct the statement, and explain the negative sign. Okay, so the amplitude is never negative. That's number one. Amplitude okay, that's number one. The amplitude is never negative. Um, that is number one. The amplitude simply measures the distance from the midline to the maximum or the min. Okay, the amplitude distance, and that's the key word. That's why we use the absolute value. It measures distance from the midline to the max and the minimum. Therefore, it can never be negative. Okay. Distance is always positive, right? Moreover, the amplitude is the absolute value of A, right? So for this equation here, we have y is equal to negative 5 sine parentheses x. What does that mean? That's saying that A is equal to negative 5. So the amplified, if A is equal to negative 5, then the absolute value of negative 5 would be a positive 5. So the negative sign does not, excuse me, the negative sign does something entirely different. What does that say? The negative sign that we have here on the 5 shows that it reflects from across the x-axis. Okay, that's what that, excuse me, that's what that basically means. All right. So the correct answer is the amplitude would be 5, and that the negative sign reflects across the x-axis. Okay, that's what that negative does. All right, so let's review. This was essentially the foundation of the graphs of sine and cosine. Again, these are the functions. Y is equal to this function for sine. Y is equal to this function for cosine. The amplitude is the absolute value of A, and it cannot be negative. If it is negative, it just shows that it reflects across the x-axis according to whatever that value is. And the amplitude for the base function is 1. The period for the base functions is 2 pi. Okay. And anytime you have to come up with points, for example, come up with 5 key points, what you can do is essentially break it up into quarters, halves, things like that. Okay. Which is what I did here. And then on the back side, we chose to use quarters as well. So we divided by 4, and it just so happened that the variation would be pi. So that's why we ended up doing intervals of pi. Okay, so just again, we divided into quarters, intervals of pi, so 0, pi, 2 pi, etc. And then over here, we had, where is it? Quarters as well, which I chose 0, and then this divided by 4, so that would be pi over 4, and then you keep going, be pi over 2, and then 3 pi over 4, etc. Okay? All right, that concludes this lesson, and hopefully I'll see you in the next one. Take care.